Hello, students. Good to see you again. We are looking at independent events. This is involved with lesson 8.3. We're going to define independent events, and I'm going to give you an example of how it works with figuring probabilities. So first of all, an independent event means that the outcome of one event does not impact the outcome of another event. So we're really dealing with two or more events at the same time. So here's an example of independent events. Like, let's say like drawing out of a deck of cards. And then rolling a pair of dice. So when you draw something out of a deck of cards, like a single card out of a deck of cards, that is an independent event of then rolling a pair of dice. So an example of how this would work is, well, let's figure out, well, what's the probability? I should probably fix this. What is the probability is what that should say. Of drawing an ace from a deck of cards, followed by rolling a 7 with a pair of dice. You would need to know what the probability of each of those is individually. Because when you have the probability of independent events, then you have what's called the probability of A intersect B. So let me write this down here for you. So when you have the probability of independent events, and let's say those events are A and B, then you can find the probability of A and B, which is going to be what they're going to call it in the book. They call it, well, what's the probability of A intersect B, or A and B? You can calculate that by taking in the probability of A and multiplying it by the probability of B. So because we're dealing with independent events, the probability of those two events, A and B, it's calculated by multiplying the probability of A times the probability of B. So that allows us, in the example you see here, what is the probability of drawing an ace from the deck of cards and then rolling a 7 with a pair of dice? Well, you would calculate, or you would find those probabilities individually and multiply their probabilities to get the overall. So to answer this question, first of all, well, what's the probability of drawing an ace? So we'll just say probability of drawing an ace. That's going to be, well, how many aces are in the deck of cards? Well, there's 4 aces in a standard deck of cards of 52. And so that probability is 1/13. And then, well, what's your probability of rolling a 7? Well, this is where you need to know the sample space when rolling a pair of dice. So without having to go into all of that, just so you know, there are 36 possible results when rolling dice. And I believe there is what? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and then 6, 1. I don't know. I kind of messed that up maybe. But if you look at all those possible outcomes of rolling a 7, that's what it's going to be out of 36. So again, that was a 1 and a 6. So we'll list them. 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and then 6, 1. So what is that? 1, 2, 3, 4, 5, 6 of them. So there are 6 out of 36, or 1/6 of a chance of rolling a 7. So what's the probability of these two things together? So what's the probability of, this is the original question, drawing an ace and rolling a 7? You would multiply those. Because they are independent events, you can just go ahead and multiply them. This is an alteration of the sum rule or the addition rule that we had in the previous lesson. We don't have to worry about any overlap. There's nothing to take out. So you don't need the summation rule. You can just simply multiply these together to get this overall probability. And so that would look like this. 1/13 times 1/6. Your chances of this happening are not very good. Well, whatever 6 times 13 is, what is that? Like 78. So you have 1 out of 78 of a chance, which is about, and if we calculate this here, I do my math right there, check my math. 60 plus 18 is 78, right? So 13 times 6, 78, and then 1 divided by 78. It's about 1% chance. It's 1.2% chance. Not great odds. If this is a game at the casino, don't play it. Don't put any money down. I mean, you can play it, but don't put any money in there. All right, kids, that is independent probabilities. Have fun with that. There's some great questions in the homework. We'll see you guys in the next video.